Students, welcome Neuron Chemistry class. We are studying here chapter 9 coordination compounds. We have already discussed the basic things of the chapter like type of ligands, IUPAC nomenclature, isomerism, structural isomerism and geometrical isomerism. Now in this video we will discuss about the optical isomerism. Students, see this video carefully. There is no need to any type of notes on WhatsApp or Telegram group for you. You can make yourself the notes by seeing the video carefully, understand the content and note it yourself the notes of the topic. Okay, and enjoy the chemistry with me. Okay, it's very interesting topic, optical isomerism. Optical means related to light. Isomerism means components are same. It means the molecular formula of the compounds will be same, but the optical nature are related to ppl are different. Okay, means like organic chemistry, the molecular formulas will be same, but there are some different configurational changes in the compound by which the optical nature of the compound is changed. Optical nature means the rotation of ppl. ppl means plane polarized light. Okay, when white light is passed through prism, it dispersed into 7 colors of the light vibgores. We get 7 monochromatic lights. When these monochromatic lights are passed through Nicol prism, we get ppl. Plane polarized light means light vibrating in only one plane. That is known as plane polarized light. We have discussed this in stereochemistry also. So the complexes which can rotate the plane of plane polarized light means ppl anticlockwise or clockwise are called optically active compounds, which can't rotate the ppl, that are optically inactive compounds. And optically inactive compound does not show the optical isomerism. Only optical isomerism is shown by optically active compounds. Okay, these optically active compounds are represent optical isomerism. The complexes are called as optical isomers. Are okay, these are of two types. As in stereochemistry also, the ppl can be rotated in anti-clockwise direction or clockwise direction. On the basis of the rotation of the ppl, the optical isomers are of two types, dextrorotatory and levorotatory. Dextrorotatory means the optically active compounds which rotate the ppl in dextro means clockwise direction. Okay, clockwise direction are termed as dextrorotatory or small d or plus isomers. Okay, dextro means clockwise, rotatory means rotation. Okay, levorotatory, where levo means anti-clockwise. Levorotatory isomers means the optically active compounds we rotate the plane of ppl in anti-clockwise direction are termed as levorotatory or small l or minus isomers. Okay, it is just same as in organic chemistry. Okay, now we will see the conditions for the optical isomers. Which compound can show the optical isomerism? There is only two conditions to show the optical isomerism. First, the compound should be asymmetric, means there should be no any type of symmetry in the compound, just like in organic chemistry. And second characteristic also as organic chemistry, the mirror image of compound should not be superimposed on the parent compound. Okay, there should be no any symmetry and mirror images should not be superimposed. We will see the optical examples of the optical isomerism in complex compounds with coordination number 4. Only single type of compounds, okay, single type tetrahedral compounds show the optical isomerism, while square planar compounds show geometrical isomerism. I have discussed already in last video. Okay, and in tetrahedral compounds only one type of compound, MAB2. M means CMA, AB2 means two bidentate ligands are present in which donor atoms are different. One is A and another is B. Like NiGly2, bis diglycosimeto nickel second. Okay, here glycinato is a bidentate ligand. I have discussed already. There is one N donor atom and second donor atom is O. Okay, so we can write this like this. Okay, so these examples, see Ni. Here NO and here NO. This is cis? No, this is not cis. This is not a square planar structure. It is tetrahedral structure. Its mirror image is this. When we want to superimpose this structure on this, we can't do this. Okay, means these are not superimposable on each other, so it is optically active compound. We can write this in full form as like this. NO is one glyoximate molecule. Glyoximate molecule is also this glycinate. Okay, this glycinato and this is also glycinato. The plane of both glycinate molecules is different. So these are not superimposable on each other. Only single type of compounds MAB2 with bidentate ligands of different donor atoms. Okay, this is the example of coordination number 4. Now we will discuss the examples with coordination number 6. Only 4 types of examples. 4 type means MA4B2 or MAA2B2. This is 4 monodentate ligands and 2 different monodentate ligands, or 2 bidentate ligands with same donor atoms and 2 monodentate ligands, or MAA3 means 3 bidentate ligands with same donor atoms, or MAA-B2C2 means 1 bidentate ligand and 2 different types of monodentate ligands in 2 number. Okay, means the condition is that there should be a bidentate ligand with same donor atom, or single example, the 4 ligands are same and 2 monodentate ligands are same. Okay, first of all we will discuss the MA4B2 or MAA2B2 type complexes. Okay, this example is also show the geometrical isomerism, cis or trans. So only cis isomer of these complexes show optical isomerism. OI means optical isomerism, while trans isomer doesn't, because mirror images of trans isomer are superimposable on parent compound. The trans isomers will be superimposable on each other, while cis isomers are not. Okay, see the example. This is the example of MA4B2 type. Its name is diaqua tetrachlorido cobaltate second third ion, or PTCN4H2 whole twice means diaqua tetracyano platinum fourth. Okay, 4 ligands are same type and 2 ligands are different type. Okay, we have to draw here the cis isomer of the compound. Cis means we will check the cis or trans position according to the less ligands, means H2O. It is cis. When we H2O is written as up and down position, that will be trans. Trans isomer does not show the optical isomers, only cis isomer show the optical isomers. Learn it. Okay, now these are the mirror images of each other and can't be superimposed on each other, so it will be optical isomer. Okay, second example, CrEn2SO4 whole twice. En2, it is a bidentate ligand with the same donor atom. Both donor atoms are N here. Okay, sulfato is monodentate ligand. Bis ethylene diamine sulfato chromate third ion. Okay, Cr, these are the monodentate ligands and these are bidentate ligand. Cis position, and it is the mirror image of this, and both mirror images are not superimposable on each other, so they will be the optical isomers. Such example for this type, COEN2Cl2 monodentate ligands and bidentate ligand with same monodentate atom. PT NH3 whole twice OX2, NH3 two monodentate ligands OX2 oxalate. Okay, where two donor atoms are oxygen. CrH2 whole twice En2, two monodentate ligands and two bidentate ligands with same donor atom. Okay, clear? Now let's see the example second, MAA3 type complexes. MAA3 type complexes means where three bidentate ligands are present with the same donor atom. Here we can take the example of ethylene diamine and oxalate as well as. Okay, FeEN3 plus 3, COEN3 plus 3, FeOX3 plus 3. Okay, here there is no any cis or trans isomer we have discussed already. They will not show the geometrical isomerism. Okay, now three bidentate ligands are attached. Okay, it is the mirror image of it. Both cannot be superimposable on each other, so it will show the optical isomerism. Clear? Okay, it is the bonding of one ethylene diamine, it is second ethylene diamine, and it is third ethylene diamine. Clear? This is the second example. Now we will discuss the third example. Third example is MAAB2C2, means one bidentate ligand with same donor atoms, two monodentate ligands and two different monodentate ligands, means three type of ligands are present. Okay, now it is very important to see that there will be three types of isomers. Okay, there will be mesoisomer is also found, not only D and L. D isomer and isomer, L isomer and mesoisomers. Okay, see the example. CrEn, ethylene diamine with same donor atoms, two chlorines and two amine. COOX, oxalate ligand, ammonia and NO2 minus. Okay, see, first of all, it is the D. When it is ethylene diamine and both B2 and C2 are at cis positions. Okay, it is D and it is its mirror image. Both are optically isomer, they cannot be superimposed on each other, and it is the transposition of one ligand, one type of monodentate ligand. Either it can be NH3 or it can be Cl. Okay, I have drawn here the NH3 at transposition. We can draw here also Cl. This is the meso compound. Meso compound means there is something symmetry. There is symmetry in this. The half part of compound will rotate the dextrorotatory direction, the PPL, and the another half part of the compound will rotate the PPL into anti-clockwise direction. So there is optical isomerism present, but net optical rotation is 0 for PPL. So it is meso compound. D, L and meso compounds. See carefully, the cis positions of two B2C2 ligands are D or L. Okay, but the transposition of one monodentate type ligand will be show the meso isomerism. Okay, one more example. See, COOX, monodentate ligand, oxygens are donor atoms, NH3 and NO2 both are at cis positions. It is its mirror image. Mirror images are not superimposable on each other, so it is D, so it is L, and it is the transposition according to NH3, or we can take the NO2 at transposition also. Here we can draw NH3 and here NO2s. Okay, this is mesoisomer. Okay, only this type of ligand show three isomers, while all the other examples show only two type of isomers, D and L. Okay, thus this is the optical isomerism, and we can conclude that only four types of complexes show optical isomerism, one type in coordination number 4 and three types of coordination number 6. Coordination number 4, MAB2 type, means here both the bidentate ligand is with different donor atoms, while in coordination number 6 the bidentate ligand should be with the same donor atom. MA4B2 or MAA2B2, MAA3 or MAAB2C2 type complexes. This is the optical isomerism and last of the isomerism. Now we will discuss some important question related to isomerism. You have to write the answers of these questions. I am explaining each and every question. Okay. First of all, which isomerism is represented by the following complexes? First, CO whole 5 MnSCN and MnCO whole 5 NCS. What is the difference in both examples? First of all, we will check the structural isomerism. there is no any ions in ionization sphere, so there will be no any ionization isomerism. There is no water molecule, so this will not show the hydrotisomers. Linkage isomerism, this is the ambidentate ligand, and where ambidentate ligands are present, the linkage isomerism is present. So it will show the linkage isomerism, means these are the linkage isomers. Okay, next, COEN3 and CrCN6, two entities are present. Here also two entities are present. The isomerism in which two identities are present was yes, coordination isomerism. There is two entities or complex ions are present, complex anion and complex cation also, so there will be coordination isomerism, there will be linkage isomerism. Next, NH3 CONH3 NO3 SO4 and CONH3 SO4 NO3. See what is the difference in both examples. There is ionization sphere is changed, so this will show the isomerism. Ionization isomerism means these examples are ionization isomers. Okay. See, COCl P/2H2O whole thrice Cl2 and COCl2 P/2H2O Cl H2O. What is the difference between these examples? H2O, which is present in coordination sphere and ionization sphere also, means this is H2O, means hydrate isomers. Okay, in this example PT Br2NH3 whole 4 Cl2 and PTNH3 whole 4 Cl2 Br2. There is also difference in Cl2 and Br2. These are present in ionization spheres, means ionization sphere is changed, so these are ionization isomers. Okay. Next question. How many geometrical isomers are obtained from MABCD type and MABCDF type complexes? Okay. MABCD type, how many isomers? 3 isomers will be obtained. And in MABCDEF type, there will be 15 type of GI and 15 type of OI. So total 30 isomers are founded. But we in question only geometrical isomers are asked, so the answer will be 15. Okay. Which compounds show the optical isomerism in the following compounds? Okay, we have to check. First of all, MCOCN6 minus 3. It is the example of MA6 type. MZNCl4. This is the example of MA4 type. COEN2Cl2. This is the example of MAA2Cl2B2. And this is the example of CuNH3 whole 4, means MA4. We have to check optical isomerism. We have discussed now the isomerism is shown by the optical isomer, by the complex compounds only of 4 types. There MA6 was not present, MA4 was not present, so only COEN2Cl2 will be the answer, and only cis isomer of this type show the optical isomerism. Okay. How many geometrical isomers are possible of these compounds? Cr C2O4 3 minus 3. It is the example of MAA whole thrice. Geometrical isomerism was not shown by this example. This type show only optical isomerism. So there will be no any of geometrical isomer of this example. In this CONH3 whole thrice Cl3, it is the example of MA3B3 type. So there will be 2 isomer, cis and trans. The cis isomer of this example is known as phase, and the trans isomer is known as mer. So phase and mer isomer will be obtained. You have to draw the structure of phase and mer isomers, and here you have to draw the structure of optical isomers of this example of cis isomer. Okay, give the optical isomers of the following compounds. MEN3 means it is the example of MAA whole thrice. we have discussed in this video type. You have to draw the examples in the structures of mirror images of this type. This example, PtCl2En2. This is the example of MAA2B2. It is AA type bidentate ligand. ठीक है. First example we have discussed this type in optical isomerism. You have to draw the cis isomer just like this. Okay, cis isomers optical structures. Okay, now this is the example CrC2Cl2En NS3. Last example MAAB2C2 type, where AA is En, B2 you can take Cl2, and Sc you can take NS3. Okay, 3 isomers will be obtained here, D, L and meso. Okay, so this is the isomerism and the questions of related isomerism in which are asked in board exam. Now this is completed the isomerism of the complex compounds. Thank you.